So we know that the derivative with respect to x of cotangent of x is negative cosecant of x squared. Okay, that comes from the textbook. But we're supposed to prove it now, only pretending that we know that the derivative of sine is cosine. The derivative of cosine is negative sine. We're only supposed to pretend that this is what we know. We need to show that this is always true, that these two sides always equal each other. Okay, so what you'll want to do for these proofs is first rewrite cotangent in terms of sine cosine. So that's cosine of x over sine of x. That's a cotangent. Okay, cotangent is cosine over sine. And now this, if you want to take the derivative, you need the quotient rule. And the quotient rule says you take the derivative of the top function. So negative sine of x is the derivative of cosine times the bottom function kept the same. And then you subtract that by the original top function times the derivative of the bottom function. The bottom function is, the derivative of the bottom function sine x is cosine x. And then it's all over the bottom function squared. Okay, so now we've taken the derivative. The calculus part's down. Now we just need the pre-calc part. Okay, negative sine of x times sine of x makes negative sine squared of x. And then cosine of x times cosine of x makes cosine squared x. And every time you see sine squared and cosine squared near each other, you want to see if you can rearrange so you can use the Pythagorean identity. Pythagorean identity says that sine squared x plus cosine squared x, that will always equal 1. Okay? And look, if you factor out a negative 1 from the top there, that's sine squared x plus cosine squared x. Right? And sine squared plus cosine squared, that makes 1. So this is 1. So that we just have negative 1 over sine squared x. And 1 over sine is cosecant. So 1 over sine squared is cosecant squared x. So we've got what we wanted to prove, cosecant squared x. So when you do a proof, you start with the left side and you keep rewriting it until it looks exactly like the right side. And we've done it. We made the left side equal the right side, so our proof is over. Same thing for this type of proof. What you want to do is rewrite this in terms of sine or cosine or both. So cosecant's the reciprocal of sine. So I'm just taking that left side, not even touching the right side. Rewriting the left side. And I can use the quotient rule again. The derivative of the top function is 0. And the bottom function is kept the same in the first part of the quotient rule. And then you subtract that by the top function kept the same times the derivative of the bottom function, which is the derivative of sine is cosine x. That's all over sine squared x, the bottom function squared. Okay, so that's the quotient rule. The derivative's done. 0 times sine of x is just 0, so that up top we have negative cosine of x over sine squared x. And we can rewrite a little bit more, because look, isn't this the same thing? Cosine of x over sine of x times 1 over sine of x. I rewrote it like that because of what we just said. Cotangent is cosine over sine, right? So this is cosine over sine. So I've got my cotangent here. This is negative cotangent x. And then 1 over sine, that's cosecant x. Okay, and that was what the right side is equal to. So we've finished it. We've completed what we sought to prove. The derivative of cosecant of x using only those two definitions of the derivative of sine is cosine, the derivative of cosine is negative sine. The derivative is down here.